Week 5, lesson 3. Okay, so let's say that we have a die, a single die, and we throw it for 60 times. That's the wrong color. There we go, 60 times in a perfect world, right? If it was landing the way that you would expect it to land, how many times would you expect it to land on a 6? Well, it should be 10. All right, again, this is theoretical probability, right? If things were just absolutely perfect and it did what you wanted it to do, but the real world is not perfect. So here are the actual results, right? So you can see that it landed on a 1 9 times, a 2 9 times, a 3 12 times, etc. Okay, so we can find these probabilities. So what this probability means is the probability that the x value, right, the random variable, was 1 happened 9 out of 60 times, right? And the probability that x came up, or the die rolled as a 2 is 9 out of 60, 3 was 12 out of 60, etc. 11 out of 60, 11 out of 60. All right, and if we want to find the mean, right? If you want to find the mean, there are 60 rolls of this die. It happened that 1 came out 9 times, and 2 came out 9 times, 3 came out 12 times, etc. All right, and if you break all of that into your calculator, you should get 3.6, okay? That is what's going to be called the expected value based on 60 trials, okay? We would expect 3.6 to come up, which I know is really, really weird because, like, on a die, you're never going to get 3.6, right? You don't have, like, pieces of a number. It's just a statistical thing, all right? So now, as the number of trials increases, right? So instead of just doing this 60 times, let's say we're doing this 60 million times, right? Then the experimental probability, right, what we just figured out, is going to approach the theoretical probability. So this is what we're going to call the theoretical probability. Again, this is more that perfect world thing, right? So the probability that is going to land on a 1 would be 1/6, and the probability that would land on a 2 would also be 1/6. So you're going to see some notation, all right? So this is the expected value of x. It's represented by letter mu, all right? And you're going to do the same computation that you did sort of above. You're going to have the number that actually comes up times the value below it, in this case 1/6, plus 2 times 1/6, plus 3 times 1/6, etc., all the way down to 6 times 1/6. And if you do all of that in your calculator, you will get 3.5. This is the theoretical probability, using the theoretical probability, this would be the expected value of x.